Part 6 of our series of video tutorials focusing on Boolean logic. In this part we're going to start to look at Boolean algebra statements and the ways in which logic gates, logic circuits and statements can be written. So we're looking at on the screen the four gates that we've previously looked at: NOT gate, AND gate, OR gate and XOR gate. Notice that the gates can be expressed in a number of different ways. Now, obviously we know that the NOT gate can be written as a triangle with the circle on the top, and the way that it's expressed in this example would be Q equals NOT A. Yep, so that defines a NOT gate. But notice that there are a number of different ways in which the NOT can be symbolized. We can have this sort of sideways L. We can have a bar across the top of the input, or we can show a NOT gate with an apostrophe. So there are three ways in which the NOT gate can be written. If we move to the AND gate, now an AND gate can be expressed as Q equals A and B. That's assuming that the inputs are in B. If the inputs were C and D, for example, Q would be Q equals C and D. Notice that it can also be written in three different ways. A dot B stands for A and B. A upside down V, if you like, B stands for A and B, or simply just A followed by B, or whatever the inputs are, would stand for an AND gate. Okay, so let's move on to the OR gate. Now, so an OR gate can be expressed as Q equals A or B. It can be written in three different ways. A plus B. Now notice the plus. That can be confusing because most people assume that plus means add. Well, when we're talking about Boolean logic and logic gates and circuits, A plus B means A or B. But it can also be symbolized with A V B. Now often the V is a superscript type version of that, but A V B means A or B. It's a, yep. Or it can be written as A or B. Right, so let's move on to the XOR gate. Well, XOR can be expressed as Q equals A XOR B. There we go. And generally is written in two different ways. A and a circle with a cross in it, B, that stands for XOR, or exclusive OR. Sometimes it will be written as A underscore V B. So A XOR B. So those are the different ways in which the single gates can be expressed and can be written. So let's move on to Boolean statements. Now, so we're looking at the statement in front of us. What we're looking at is not A and B and C. Now, the way that this can be written, and the way it would often be written, would be enclosed in parentheses the not symbol, or you might have the bar across the A, of course. So within parentheses the OR symbol, which is the inverted V, if you like, and then in brackets B and C. Again, the inverted V being used for AND. So brackets not A and brackets not brackets. Oh, let's try that again. Brackets not A and brackets B and C. So this expression equals that circuit. Now we've covered the truth tables before, so we won't do that again. So if we look at the second circuit, so we've got an OR gate, an AND gate, and AND gate, and we've got inputs to A and B, inputs to C and D, which feed into our result, which would be Q. So we've got an OR gate and AND gate. So and the way that is written is in parentheses A or B. Again, we're using the V to symbolize B. We could of course use the plus. A or B, and symbol, which is the inverted V, C and D. Okay, so let's move it on. Let's move on to this next one. Well, what we're looking at here now, highlight it, is an XOR gate, an AND gate, and an OR gate. Okay, so how's that written? Well, if we look at it, we have parentheses a XOR symbol, which is the bar under the V, a XOR symbol B, then parentheses, and again in parentheses C or D. The use of the brackets, the use of the parentheses, is separating out the logical operations that apply to each gate. And that's important that we notice that. And if we look at the final one, we have 3 XOR gates. Now, so the 3 XOR gates, well, if we look, there's parentheses around both of them. So A XOR B, XOR C, XOR D. Yep. And so that allows us to write out that Boolean circuit, or logic gate circuit, as a Boolean statement. Okay, thank you.